Chemical Safety Handling, E-Safety Training. Course Menu. General, Chemical Substance, Arsenic, Benzene, Hydrogen Sulfide, Mercury. Emergency Response, Handling and Disposal. Examination. Welcome to our e-safety learning on chemical safety handling. This course will present the safety requirements and safe work practices to properly handle chemicals. It will require you approximately 30 minutes to finish the course, and you are not allowed to skip any chapters. Begin the post-test immediately after you complete all the chapters. Let's start now. Our key objectives are to see it that you understand chemical substance principles and characteristics and their hazard. Apply chemical safety awareness practices when you are working in PTTEP operations. Understand the standards used in PTTEP's chemical management. Understand effective waste management for chemical substances. Chapter 1. General. Physical characteristics, toxic and chemicals, health effects, exposure routes, target organs, monitoring, protection. General. Physical characteristics. 1. Solid. 2. Liquid. 3. Gas. Toxic and chemicals. 1. Chemical properties. Example, acid, base, explosives. 2. Physical properties of chemical substances. For example, gas, liquid, solid. 3. Exposure volume. 4. Timing. 5. Individual tolerance. 6. Age. 7. Gender. Health effects. Signs and symptoms are classified into 2 time phrases. 1. Acute immediate effect such as skin and eye irritation, skin burn and unconsciousness. 2. Chronic long-term effect such as carcinogenic paralysis, teratogenesis, death. Exposure routes. Chemical exposure can occur through inhalation, ingestion, absorption, injection. And chemical elimination occurs through secretion such as snot, tears, saliva, breastfeeding, sweat, urine, and feces. Target organs. Repeated or prolonged exposure to the substance can produce damage to target organs. For example, mercury may be toxic to upper respiratory tracts and central nervous system. Monitoring. Occupational exposure limit consists of threshold limit volume, time weighted average, TLV/TWA, is an average exposure on the basis of an 8 hours day or 40 hours week work schedule. Threshold limit volume, short-term exposure limit, TLV/STEL, is a spot exposure for a duration of 15 minutes that is repeated more than 4 times a day with at least 60 minutes between exposure periods. Threshold limit volume, ceiling limits, TLVC, is an absolute exposure limit that should not be exceeded at any time. Different chemicals have different TLV. Protection. Chemical protection can be provided by the means of the 1. Source. For example, substitution of less toxic chemical. 2. Pathways. For example, putting on a hood. 3. Receiver. For example, wearing adequate PPE. Hierarchy of controls. An effective hierarchy of controls is divided into 5 levels of control. 1. Elimination by physically removing the hazard. Example, process control, enclosure and/or isolation of emission source. 2. Substitution by replacing the hazard. For example, changing the chemicals or raw material. 3. Engineering controls by isolating people away from the hazard. Example, ventilation, isolation of the hazardous area. 4. Administrative controls by changing the way people perform the work. For example, good housekeeping, education and training, emergency preparedness, personal hygiene practices, and clean facilities. 5. Regulation to wear PPE by protecting the workers with personal protective equipment. For example, safety shoes, gloves, and helmets. Chapter 2. Chemical substance. Arsenic. Benzene. Hydrogen sulfide. Mercury. Arsenic. Inorganic arsenic. Arsenic exists in different chemical forms, which can be classified into 2 groups: organic arsenic and inorganic arsenic. Inorganic arsenic can be a concern to human health. Arsenic appears in 3 allotropic forms: yellow, black, and gray. The stable form is a silver-gray brittle crystalline solid. Arsenic is one of the most toxic elements that we must always remain aware of. Arsine is an inorganic compound with the formula ASH3, which has garlic odor. This flammable, pyrophoric, and highly toxic to human. Liquid arsenic is a clear, colorless, aqueous solution, and several drops in a glass of wine or water could kill a person. Sources of inorganic arsenic exposure include foods, trace amounts, smoke from burning wood, coal, and tobacco products, dust from some industrial processes, for example, smelting industry, coal power plants, and chemicals. Petroleum. Arsenic-contaminated petroleum products such as crude, condensate, produced water. Drinking water that contains arsenic. Arsenic-treated wood. Soil. Exposure routes. Dermal and oral exposure are major routes of exposure to arsenic, although inhalation exposure and eye contact are also important routes to remember. Health effects. Arsenic toxicity are classified into 2 time phrases: acute effects, nausea and vomiting, bloody diarrhea, severe abdominal pain, encephalopathy, cardiovascular collapse, shock and death. Chronic effects. Exposure to inorganic arsenic over a lifetime can increase the risk of some cancers, such as bladder, liver, kidney, lung, and skin cancer. Long-term exposure to high level of inorganic arsenic over many years or decades may also cause decreased production of blood cells, abnormal heart rhythm, numbness of hands and feet. Prevention and control in workplace. Don't eat, drink, or smoke in workplace area. Wear the appropriate PPE for the job, for example, gloves, goggles, helmet, and safety boots. Wear a respiratory, especially when arsenic levels in the air exceed the time-weight average. Measure the inorganic arsenic in workplace. Prevention and control. Remove your PPE and work clothing at the end of your shift and leave them at work. Decontaminate after work shift by showering. Inorganic arsenic monitoring. Medical monitoring can be performed by collection one of the following: blood, urine, nails, or hair. PTTEP monitors inorganic arsenic exposure by urine sampling. Normally, the best time to collect urine for inorganic arsenic testing is at the end of the work week. Benzene. Characteristics. Benzene is an important organic chemical compound with the chemical formula C6H6. This chemical is colorless or a light yellow liquid at room temperature and has a sweet odor. Is highly flammable and evaporates into the air very quickly. Its vapor is heavier than air and may sink into lower lying areas. Benzene dissolves only slightly in water and will float on top of water. Sources of exposure. Natural source of benzene include volcanoes and forest fire. Benzene is also a natural component of crude oil, gasoline, and cigarette smoke. Some industry use benzene to make other chemicals that are used to make plastic, resin, nylon, and synthetic fibers. Benzene is also used to make some types of lubricants, rubbers, dyes, detergents, drugs, and pesticide. Exposure routes. Inhalation exposure is the major route of exposure to benzene, although oral and dermal exposure routes are also important. Health effects. Acute effects on human are drowsiness, dizziness, rapid and irregular heartbeat, headache, tremors, confusion, unconsciousness, death at a very high level exposure. Chronic effects harm bone marrow and can cause a decrease in red blood cells, leading to anemia. It can also cause excessive bleeding and can affect the immune system, increasing the chance of infection. Benzene causes cancer in humans. Long-term exposure to high levels of benzene in the air can cause leukemia. Prevention and control. Remove your PPE and work clothing at the end of your shift and leave them at work. Decontaminate after work shift by showering. Benzene monitoring. Medical monitoring can be done by collection of either blood or urine. PTTEP monitors benzene exposure by urine sampling. The best time to collect urine for benzene is at the end of a work shift. Hydrogen sulfide. Characteristics and sources. Hydrogen sulfide is colorless, flammable, and extremely hazardous gas with a rotten egg smell. It occurs naturally in crude petroleum and natural gas. Toxicity. Acute. Respiratory paralysis, acute poisoning, or strangulation may occur after even a few seconds inhalation of high concentration of hydrogen sulfide, causing panting, pallor, cramps, paralysis, and almost immediate loss of consciousness. Death may follow quickly from respiratory and cardiac paralysis. Chronic effects. Long-term exposure of more than 3 months. Depression, dizziness, and blurred vision. Loss of sleep, shortness of breath and headaches. Insomnia. Decreased corneal reflex, convergence and divergence. Standard and detection. Acceptable exposure limits are as follows. Time weight average TWA, not to exceed 1 ppm. Short-term exposure limits, 5 ppm. Detector. There are several pieces of special equipment for detecting hydrogen sulfide. 1. Personal hydrogen sulfide detector. 2. Hydrogen sulfide detective tubes, pumps. 3. Standalone hydrogen sulfide gas detector. 4. Fixed system hydrogen sulfide gas detector. Detection. Example. Hydrogen sulfide detective tubes, pumps, brand and dagger. 1 pump stroke equal 100 milliliter. Measuring range equal 0 to 2000 ppm. Portable hydrogen sulfide gas detector model Max XT. Audible and visual alarm. Low alarm 1 ppm. High alarm 5 ppm. Measuring range 0 to 200 ppm. Equipped with circulating pump, requiring calibration. Crocon detector model Detective Plus. It detects and measures 3 or 4 gases, hydrogen sulfide, carbon monoxide, methane, and oxygen, depending on detector type. Protective equipment. There are various types of equipment used on field. They include escape mask with cartridges, SCBA working set, breathing air supply set. Mercury. Characteristics. Mercury is a chemical element with symbol Hg and atomic number 80. It is commonly known as quicksilver and was formerly named hydrogerum. A heavy silver D-block element, mercury is the only metallic element that is liquid at standard conditions for temperature and pressure. Source. Mercury is a trace component of all fossil fuel, including hydrocarbons produced from reservoir, so it is also found in natural gas, condensate, and the produced water, sand, and mud that comes from wells and internals of process equipment. Forms and risk. Mercury has 3 forms. 1. Elemental mercury is a metallic silvery liquid, also known as quicksilver. Readily breaks into droplets and vaporize at room temperature into an odorless, colorless vapor that can easily be inhaled. 2. Organic mercury. Methyl mercury is most commonly found in the environment. It bioaccumulates in the environment and is most commonly found in fish. Oral ingestion through eating of fish is the most common route of exposure of mercury to human. 3. Inorganic mercury can enter the body through the mouth and skin from products such as disinfectants and fungicides. Routes of exposures. 1. Inhalation. Inhalation of mercury vapor is the primary route of exposure to elemental mercury. Inhaled vapor can be almost 80% absorbed by the lungs. 2. Ingestion. Ingestion of food is one of the most frequent ways in which people get mercury poisoning. 3. Skin-eye contact. Elemental mercury vapor is very slowly absorbed through the skin in high concentrations and causes irritation of both skin and eyes. It may produce contact dermatitis as well. Toxicity. The degree of toxicity varies on the concentration, exposure period, route of exposures, and mercury forms. Health effects. 1. Acute exposure. Conditions are severe and sudden in onset. The mercury content is about 0.02 grams approximately. Vomiting, stomachache, diarrhea, faints, urinary retention, dead. 2. Chronic exposure. Repeated or continuous exposure to elemental mercury can result in accumulation of mercury in the body and permanent damage to the nervous system and kidneys, resulting in anxiety, irritability, anorexia, loss of appetite, insomnia, sleeping problems, fatigue, forgetfulness, tremors, changes in vision, changes in hearing. Safe work precautions. To be considered a safe work area, the area must maintain an atmosphere contamination of less than 0.01 microgram per cubic meter. When working with potential mercury contamination, the area must be sealed off and controlled. When working with or staying in an atmosphere of contamination of more than 0.01 microgram per cubic meter, chemical protective clothing, nitrile gloves, safety boots, helmets, chemical safety goggles, aprons. Detection. The concentration of mercury needs to be measured for further safe work practices and the control of mercury-contaminated areas. Additional detection devices include 1. Mercury reactive tubes, gas stick and dragger. 2. Mercury vapor analyzer, Jerome RI. 3. Mercury detecting personal badge, Sapphire. Different measurement has different concentration range since 0.01 microgram per cubic meter to 999 microgram per cubic meter. Mercury testing. Mercury testing is performed to detect the presence of an excessive amount of mercury in a person's blood and/or urine sample. The blood test result will be used to indicate any recent exposure. On the other hand, a urine test result will be used to indicate any long-term exposure. To evaluate ongoing exposure to mercury, such as exposure during occupational work, the urine test for mercury is not used for testing mercury, as this sample comes from dietary intake. A result greater than 20 microgram per gram creatinine may indicate a hazardous level of mercury in the body. Personnel who may be exposed to mercury at work must also undergo a mercury urine analysis before beginning and after completing a job. Personnel showing a positive result must be kept away from potentially mercury-contaminated areas. Waste management. Mercury-contaminated waste must be separated from other waste to avoid contamination. The following are examples of waste that may be mercury, Hg contaminated waste. Produced water, wastewater, spent catalyst, absorbents, ceramic balls, sludge, used PPE, contaminated empty containers, pipes and spools, used filters, membranes, elemental mercury, fluorescent lamps, mercury thermometers, etc. Chapter 3. Emergency Response, SDS. Spill Management. The Spill Kit. SDS. Each chemical differs in its emergency response. It is identified in the SDS and is available at your work area. The workforce should learn all the steps in correct material handling and storage, as well as the appropriate response method in the event of a spill or chemical exposure. Spill management. In case of a chemical spill, please follow your specific site's emergency response plan. Before taking any other action, contact your emergency call number and then give your name of the reporter, what, where, and how much was spilled. The emergency response team will respond to the spill based on the information in the SDS. The spill kit typically consists of gloves, absorbent pads, sheets, goggles, aprons, and disposable bags. Periodically check the spill kit to see whether supplies needs to be replenished. Additional supplies may be obtained from SHE department. Chapter 4. Handling and Disposal. General guidelines for temporarily on-site storage. Waste disposal shall comply with the PTTEP waste management procedure. All personnel involved in waste disposal shall wear appropriate PPE. Chemically contaminated wastes are classified as hazardous waste. All hazardous waste shall be kept in secured containment with correct labeling. Hazardous waste storage areas shall be clearly defined and surrounded with bunds and connected to specific drainage. No smoking or eating around storage spaces. Inventory records shall be kept for all types of waste, their descriptions, their quantity in storage, and their initial placement dates into storage. Monitoring of mercury vapor after sealing its containers and prior to transferal to other locations is recommended to ensure no release of mercury vapors occurs.